Hi guys, welcome back to this online course on Introduction to Construction Technology. In our previous sessions, we saw in detail about the types of concrete mixes, the requirements of concrete mix design, the mix proportion designation, factors affecting mix proportion, factors to be considered for mix proportion for different grades of concrete, the procedure to calculate the water cement ratio for mix design, and the calculation of water cement ratio for M30 grade of concrete. In this session, we are going to learn about the concrete mix design in detail. In this session, we will see in detail about the data required for mix design, the design procedure, and the mix design for M40 grade of concrete with and without using fly ash. So now let's move on to the session. So first, let's see about the data required for concrete mix design. The important data required are the grade of concrete for which we are going to do the concrete mix design, the maximum size of aggregate, that is as per IS code, the minimum cement content, the maximum water cement ratio, the workability in terms of slump, that is the slump cone test which we do for checking the workability of concrete. So that should be done. The data from the slump test is required to calculate the concrete mix design. The exposure condition of the materials, that is the aggregate, cement and sand, fine aggregates. That should be specified whether it is severe or mild or moderate or very severe or extreme. That has to be taken into account. The maximum temperature at the pouring point, early age strength if required, but we don't consider that much. Grading zone of fine aggregates, that is as per the table, whether it is in zone 1 or zone 2 or zone 3. The type of aggregate, mostly the type of aggregate should be angular. That should be noted. It is an important criteria for concrete mix design. The maximum cement content, the admixture used if required, specific gravity of all materials used, that is cement, water, fly ash, admixtures, all those specific gravity of the materials for admixtures should be identified. Then the moisture content should be free for aggregates, that is the fine and coarse aggregates should be in dry condition. So now let's see the procedure for concrete mix design. I have listed down the steps which needs to be followed for calculating the concrete mix design. First one is to calculate the target mean strength of concrete. That is calculated using the formula F-CK is equal to FCK plus 1.65 S, where F-CK is the target mean strength of concrete, FCK is the characteristics compressive strength at 28 days. And S is the standard deviation that can be obtained from IS 10262-2009 table 1. As we have seen earlier, for M10 and M15 concrete, it is 3.5 Newton per mm square, and for M20 and 25 concrete, it is 4 Newton per mm square, and for concrete grade of from M30 to M55, it is 5 Newton per mm square. All these above values corresponds to the site control having proper storage of cement, weight batching of all materials, controlled addition of water, regular checking of all materials, aggregate grading, and moisture content. If it is not periodically checked for workability and strength, value shall be increased by 1 Newton per mm square. Or if the material or all conditions are up to the standards, then the same values can be considered. So with this formula, we will calculate the target mean strength of concrete. Next is the selection of water cement ratio. This is obtained from table 5 of IS 456-2000, and it can be taken depending upon the exposure condition. Here the grade of concrete doesn't play a role on this. This mainly depends upon the exposure condition. If it is mild and this one is for plain concrete and this table is for reinforced concrete. So if the exposure is mild and the minimum cement content will be 220 and the free water cement ratio is 0.6. If it is moderate, it is 240 and water cement ratio is 0.6. For this table is for plain concrete and this is for reinforced concrete. If our condition is very severe and if we are following in for then the minimum cement content is 340 and if it is not severe it is 320. The water cement ratio for both the condition is 0.45. So this is how we calculate the water cement ratio as per table 5 of IS 456-2000. Minimum grade for plain concrete under mild exposure condition is not specified here. You can see here the grade is not specified. So for grade M5, 10 or M7.5, these values can be followed. So next is the selection of water content. From table 2 of IS 10262-2009, the maximum water content for 25 mm to 50 mm slump is 186 kg, that is 186 liters. You can see here that the nominal maximum size of aggregate is 20 and the maximum water content is 186 kg. So, for additional slump, 3% may be added for every 25 mm slump. So, if the slump value is 75 mm, then 3% additional slump is added. If it is 100 mm, then 6% is added. So, we can see that in the examples what we have considered. So, the water content corresponding to the main thing is the aggregate should be in dry condition. Should not be under wet conditions. That is the main criteria we have to consider here. So next is the selection of cement content. I have explained with an example how to calculate the cement content. This is calculated from water cement ratio. The minimum cement content is taken from table 5 of IS 456. So here W is equal to 186. So the water cement ratio is 0.45. For example, I have taken this. So the cement content is equal to 186 divided by 0.45, which is 413.33 kgs. This is the cement content for this value of water cement ratio and W. Okay, next is the volume of coarse aggregate and fine aggregate. Earlier we have calculated the target mean strength, then we calculated the cement content, then the water content, and now it is the coarse aggregate and fine aggregate content. So the proportion of volume of coarse aggregate and fine aggregate can be determined from this table 3 of IS 10262-2000. This is depending upon the fine aggregate zone. So, if you see the table, this is the volume of coarse aggregate per unit of total aggregate for different zones of fine aggregate. So, here it is indicated in zone. Zone 1, Zone 2, Zone 3, Zone 4. And this value for 20 mm size of aggregate is for Zone 1 it is 0.6, for Zone 2 is 0.62, Zone 3 is 0.64 and Zone 4 is 0.66. This aggregate values are also volume based and it is in saturated surface dry condition. So next is the mix calculation. The mix calculation per unit volume of concrete is calculated as follows. For example, we are taking a volume of concrete as 1 meter cube. So the volume of cement is calculated by using the formula mass of cement by specific gravity of cement into 1 by 1000. And the volume of water is equal to mass of water by specific gravity of water into 1 by 1000. The volume of chemical admixture is calculated using the formula mass of chemical admixture by specific gravity of admixture into 1 by 1000. So next, after calculating the volume, we have to calculate the volume of total aggregate. That is the fine aggregate and the coarse aggregate in the cement. So it is calculated using the formula A minus B plus C plus D, where A is the volume of concrete, that is 1 meter cube. Volume B plus C plus D is the volume of cement plus volume of water plus volume of chemical admixture. You can see here. From this we will get the volume of aggregate. Then we have to calculate the mass of coarse aggregate. Mass of coarse aggregate is calculated using the formula E into, where E is the volume of aggregate, that is the volume of total aggregate, into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. This will give the mass of coarse aggregate. Next, we have to calculate the mass of fine aggregate, which is calculated the same way as that of coarse aggregate and with the same formula, but there it is coarse aggregate and here it is fine aggregate, which is equal to E into volume of fine aggregate into specific gravity of fine aggregate into 1000. So after calculating all these values and depending upon the codal provisions, we will come up with the mixed proportion for cement in kg per meter cube and water in kg per meter cube, the fine aggregate in kg per meter cube, coarse aggregate in kg per meter cube, chemical admixture in kg per meter cube, and water cement ratio. So from this mixed proportion, we can arrive at the mixed ratio of cement, fine aggregate and coarse aggregate. So this will be in the form of 1:2:4. Example 1:2:3. In any ratio, it will be identified. So this is the procedure to calculate the concrete mix design for any grade of concrete. So let's see it with an example, so that it will be clearly understood. So now let's see the concrete mix design for M40 grade. The data required for calculating the concrete mix design is grade designation. So the grade of concrete used here is M40. The type of cement is OPC 43 grade conforming to IS 8112. This is the code for 43 grade cement. The maximum nominal size of aggregate used is 20 mm. The minimum cement content is 320 kg per meter cube, and this value is taken from table 5 of IS 456/2000 depending upon the exposure condition. Here the exposure condition is severe. So if you see table 5 of IS 456 for severe condition, for reinforced concrete, the minimum cement content value is 320 kg per meter cube and the water cement ratio is 0.45. These two values is what I have considered here. The minimum cement content is 320 kg per meter cube and the maximum water cement ratio is 0.45. So the workability of concrete here I have taken as 100 mm because the slump value I have taken here as 100 mm because it is a pumpable concrete. So for pumpable concrete, normally we use the slump cone of 75 mm to 100 mm. So I have taken the higher side of 100 mm. The exposure condition, as I said, I have considered here as severe and it is for reinforced concrete. So next the values I have taken is method for concrete placing is by pumping. Degree of supervision is good and the type of aggregate used is crushed angular aggregate. This is a important criteria to be considered for this mixed design. The aggregate should be of angular type. And the maximum cement content is 450 kg per meter cube. The chemical admixture I have used here is superplasticizer. So the test data for materials with this is obtained from the manufacturer or vendor of the materials which we are using. That is, the cement used should be of OPC 43 grade. It can be of 53 grade also, but it should conform to the corresponding Indian code. That is, for 43 grade it is IS 8112. The specific gravity of cement is 3.15. The chemical admixture here is superplasticizer conforming to IS code 9103 is considered. So these are some of the values which is required for doing the concrete mix design. The specific gravity of coarse aggregate is taken as 2.74 and the fine aggregate is 2.74. Water absorption for coarse aggregate is 0.5% and fine aggregate is 1.0%. The free surface moisture for coarse aggregate and fine aggregate is considered nil because the aggregate should be in dry condition. It should not be used in wet condition. The sieve analysis test for coarse aggregate and fine aggregate should conform table to IS code 383, and coarse aggregate should be followed as per table 2 of IS 383, and fine aggregate should conform to the grading of zone 1 or zone 2 or zone 3 as per table 4 of IS 383. So first we have to calculate the target strength for mixed proportioning by using the formula F dash CK is equal to FCK plus 1.65 S, where F dash CK is the target average compressive strength at 28 days, FCK is the characteristic compressive strength at 28 days, and S is the standard deviation. So from table 1 of IS 10262 2009, the standard deviation is calculated for M40 grade concrete as 5 Newton per mm square. Therefore, the target strength is equal to 40 plus 1.65 into 5, which is equal to 48.25 Newton per mm square. So we have calculated the target strength. Next is the selection of water cement ratio. The selection of water cement ratio is taken from table 5 of IS 456 2000 depending upon the exposure condition. Here it is severe, so the maximum water cement ratio is 0.45, and based on experience we have adapted a water cement ratio of 0.4. Always a water cement ratio, the lesser the water cement ratio value is what we consider for mixed design, or normally that is what we considered. We have seen in the earlier session about how to calculate the water cement ratio. In that also we will take the lower value of the water cement ratio. So here the water cement ratio adapted here is 0.4, which is less than 0.45 from the table. So it is hence okay. So next we have to calculate the selection of water content. We have calculated the water cement ratio. Next is the water content. This water content is also taken up from the table 2 of IS 10262 2009. The maximum water content for 20 mm aggregate is 186 liters. For 25 mm to 50 mm slump range, for this slump range it is 186 liters. So I will show you simultaneously. I think you will get a clarity. For 20 mm aggregate, size of aggregate, it is 186 kg, the maximum water content. So it is 186 liters. 186 kg, we are changing the units to liters. So the estimated water content for 100 mm slump. So as I said earlier, for every 25 mm slump increase, you can add a 3% to the value. So for here I have increased 50 mm slump. That value 186 is for 25 to 50 mm slump. Here it is 100 mm slump. So I have added 6% to this value. So it is 186 plus 6 by 100 into 186, which is equal. So it is 197 liters. So this is the estimated water content. As a superplasticizer is used, the water content can be reduced up to 30%. That is, it can be reduced till we can use up to 30%. Based on the trials, the water content is reduced by 29%. So by using the superplasticizer. So the arrived water content here is calculated by 197 into 0.71. This is the from 100% we have reduced this 29% of water content, and we have calculated the arrived water content. So it is 197 into 0.71, that is equal to 140 liters. This is the arrived water content. So next is the calculation of cement content. The water cement ratio is 0.4. The cement content is 140 liters. Now we can calculate this value 140 by 0.4. We get the cement content as 350 kg per meter cube. This value is greater than 320 kg per meter cube, which is from table 5 of IS 456. So for severe exposure condition. So we can follow up with 350 kg per meter cube as it is greater than the table value. So now next is the calculation of volume of coarse aggregate and fine aggregate content. This is calculated from table 3 of IS 10262-2009. That is for 20 mm size aggregate, and for fine aggregate zone 1 water cement ratio, that is 0.6. If I show you the previous slide with the table, you will get still more clear. You will become still more clear. See, for maximum size of aggregate 20 mm, for zone 1 it is 0.6. This is where I have taken the value from table 3. So if you see here, it is 0.6. So in the present case, the water cement ratio, whatever we have calculated, is 0.4. Therefore, the volume of coarse aggregate needs to be increased. Since the water cement ratio for that coarse aggregate is 0.6, we have to increase the coarse aggregate to decrease the fine aggregate content. So for that, the water cement ratio should be added, that is plus or minus 0.1 for every 0.05 change in water cement ratio has to be added. So we have to increase the proportion of volume of coarse aggregate by 0.02. So the corrected volume of coarse aggregate for water cement ratio of 0.40 is equal to 0.62. And mainly we have to keep in mind that the coarse aggregate is of angular type, and the volume of coarse aggregate may be required to be increased suitably based on if it is not of angular type, then again the volume of coarse aggregate should be increased suitably. So this is how we have calculated the volume of coarse aggregate and fine aggregate using the table. Next is the concrete is poured by pumping concrete, so it is called pumpable concrete. And if it is pumpable concrete, then the values can be reduced again by 10%. So the volume of coarse aggregate, that is 0.62 into 0.9. This from 100% I have reduced to 10%. So it is 0.9, which is equal to 0.56. So the volume of fine aggregate content is 1 minus this value 0.56. It is 0.44. This is how we calculate the volume of coarse aggregate and volume of fine aggregate. So next is the mix calculation. In this calculation, we will be finding out the volume of cement, water, fly ash, chemical admixture, everything for per unit volume of concrete. So A value is volume of concrete, which is 1 meter cube, and volume of cement is equal to mass of cement by specific gravity of cement into 1 by 1000. Here the mass of cement, what we have calculated here is, you can see here the mass of cement is 350. So this is the value which we have considered here, 350 by specific gravity of cement into 1 by 1000. So we arrive at 0.111 meter cube. So the volume of water, that is a mass of water by specific gravity of water. The mass of water here is 140 liters. So we have taken this 140 liters divided by specific gravity of water is 1 into 1 by 1000. So it is 0.140 meter cube. Next is the volume of chemical admixture, which is equal to mass of chemical admixture by specific gravity of admixture into 1 by 1000. The same way it is 7.6 by 1.145 into 1 by 1000, which is 0.6006 meter cube. Next is the calculation of volume of total aggregate, that is fine aggregate and coarse aggregate. This is calculated by using the formula A minus B plus C plus D. This A is the volume of cement, B plus C plus D is volume of cement plus volume of water plus volume of chemical admixture. So this is how we calculate the volume of aggregate, and the value here is 0.743 meter cube. Next we have to calculate the mass of coarse aggregate. We have calculated all the volumes. Next is the calculation of mass of coarse aggregate, which is calculated using the formula E into, where E denotes the volume of the total aggregate. That is the value which we have calculated above. So it is E into a volume of coarse aggregate into specific gravity of coarse aggregate into 1000. So it is 0.743 into 0.56 into 2.74 into 1000, which is equal to 1140 kilogram per meter cube. Next, we have to calculate the mass of fine aggregate the same way as we have calculated the mass of coarse aggregate. So here it is E into volume of fine aggregate into specific gravity of fine aggregate into 1000, which is equal to 0.743 into 0.44 into 2.74, which is the specific gravity of fine aggregate, into 1000, which is equal to 896 kg per meter cube. Thus, we have calculated the mass and volume of all the ingredients used in the concrete. Now, let's calculate the mix proportion for the trial mix. So here the cement value is 350 kg per meter cube, water used is 140 kg per meter cube, fine aggregate is 896 kg per meter cube, coarse aggregate is 1140 kg per meter cube, chemical admixture is 7 kg per meter cube, and water cement ratio is 0.4, which is the lowest, and the trial mix ratio, therefore it is 1:2.56 is to 3.26, that is cement is to fine aggregate is to coarse aggregate. So while doing the concrete mix design, we have to keep in mind of two conditions, that is the slump value, which is calculated by slump cone test for the concrete, can be the water content or the dosage of admixture can be adjusted to achieve the required slump that is required for the mix proportion. And one more thing is 2 or more trials of variation of 10% water cement ratio should be carried out, and their values should be plotted in as per the graph what we have seen in the calculation of water cement ratio for the given target strength of the concrete. So, the final aim is the durability of the concrete should be met. We should not compromise on the durability. So, this is how we have to calculate the concrete mix design for M40 grade of concrete. Hope I have made clear on this design calculation.